You are listening to another podcast from litfuse.com.au.
Welcome, Tim. Thanks very much, Joe. I'll launch straight into the presentation, having seen how quickly 5 minutes does go. The topic is the power of optimisation, and clearly that's the foundation stone for our business. And optimisation is really about the process of determining the best possible solution for a problem. And clearly with water systems, what we are dealing with are extremely complex problems. And what we have is a benchmark problem, the New York tunnels, which is on face value a very simple problem that consists of 21 tunnel realignments that was developed in 1969 when they were looking at future demands for New York. And we use this as an example about the number of combinations and variations that can come up with a simple problem. And if you look at the bottom, that if you have 16 different possible diameters to reproduce this network for increased needs and demands, 16 to the power of 21, number of choices to the number of decisions, is the number of combinations per individual pipe choices. So you're talking about a fairly simple system, but a phenomenal number of pipe choices that could be made to develop that system. If you disregard a large percentage of those, 99.9999% of those due to engineering judgment, you're still looking at 1.93 by 10 to the power of 18. If you did that linearly, in considering each pipe choice as you go, you're still talking about, with 10 options per second, 6 billion years to actually compute that problem. So clearly what we're talking about is the ability to deal with now very, very complex problems is the power of a number of different technologies that we've coupled together to make that work. As Joe mentioned, we are the leader in water systems optimisation, and our technologies have been developed out of the University of Adelaide, established in 1996. And what we do is we harness mathematical algorithms, engineering judgment, and purpose-built computing applications to be able to deal with these complex problems. The core technology that has really launched our business and continues to be a powerful part of our offering is the Optimisation genetic algorithm. And as you can see, that a water system has a number of different inputs that are needed to be considered, let alone just pipe choices. So what we do is we consider each of those within a genetic algorithm and come up with optimal decisions throughout the water infrastructure system, be that water distribution or wastewater collection. All going well, we then apply that genetic algorithm to be able to use a directed search technique. And what that does is that it continues to work on what starts as random choices for selections for your pipes, pumps, water sources, and then directs those down, picking the most effective as you go, and enables you to evaluate millions, if not billions, of options. It then enables you to choose from these a convergence of the best solution alternatives. Here we have an example of our technology in activity there, and this is actually a project that we did for Bonita Springs in Florida. And you can see on the right, on my right, the pipe choices that we're running through here. This is a 1100 pipe system, and on the left-hand side is actually the trending, where you're seeing a generation each hit across that bar at the bottom is 180 different network designs for 1,100 pipe choices and 7 water sources and 15 pumping stations. And you can see that the blue line at the top is actually the cost of actually implementing that solution. So you can see that it is trending, and as the colours start to settle down, they are the optimal pipe choices and pumping choices that you have. And at the bottom is a penalty that we provide to make sure that it works from an engineering perspective. Our markets are in the United States. The orange dot there is Chicago, which is our office that we've had since the mid-90s. And the green dots are the projects that we've actually completed in the US. I picked a couple that I thought may be of use. We're currently working with the City of Las Vegas for water quality optimization for moving water through its system. We're also working with Johnson County in Kansas City for the optimization of a wastewater collection project. In the UK, we've been there for 4 years. We have a dot, which is Oxford, which is our office that we've set up there. We're currently working with United Utilities for customised software for risk management, for pipe criticality, which is leakage and pipe burst. And we also are working with Three Valleys Water. They've got 150-year-old water mains, and what we're doing is that we're using our technology to optimise the replacement of those pipes from both a cost perspective and also a minimum disruption to traffic as well. In Australia and New Zealand, we have projects with Murrumbidgee Irrigation that we've completed for channels to pipes optimisation. City of Auckland, we've recently completed the master plan for 2057, which is to take the future of water sourcing for the entire City of Auckland. I started with a very simple problem. This is the City of Auckland, which you can see is a far different proposition, and what we were previously looking at to be able to model the entire scenario out to 2057 is actually a process that now will be done in a couple of days using our computing technologies. There's the need, and to give an indication of demand, in the US alone we're looking at $1 trillion to be able to meet the current regulatory and also demand requirements across a 20-year period which we're currently in. They've allocated $500 billion, and what we do is we work with the water utilities to be able to optimise their ability to meet their requirements and to be able to get the best possible solution with a minimal investment and meet the requirement for that water city. Thank you.